What you're looking at here is a homemade TV lift for my computer. I mounted it to my $2 Goodwill desk so I can optimize space and also stow it away when the computer isn't in use. It's all metal construction with scrap from old projects. The linear rails are just heavy-duty drawer slides, and the drive is a spare 8mm Acme screw for my CNC plasma cutter build. The only thing that I had to buy was the drawer slides. Everything else was extra from old projects. I originally started this build with this exact rough sketch. This is enough for me to build it off of. I generally don't draw things out at all, but for your entertainment purposes, I did this CAD file so you can better understand the interaction between the drawer slides, the linkage, and the drive mechanism. So you can see the screw turning, and that physically moves the linkage that pushes on the drawer slides. My Portaband was great for the majority of the cutting, but the plasma cutter saved me a mountain of time for the bigger cuts. The cut quality can be harder to maintain, especially when the tip fails mid-job, but it's still worth the trouble in my opinion. For some reason, I decided to use my stick welder to put the structure together, but after hundreds of hours of using high-dollar Miller welders, the Chicago really isn't that good. But you can't beat it for the money, I suppose. The goal here is to keep everything fairly square while I weld it together, but this isn't the important part, so we're going to save our energy and just lay down good, strong welds. Once the drawer slides come into play, the real work begins. The slides need to be mounted perfectly parallel to each other to ensure they don't bind up as they move. Next, I drill the holes in the front face of the structure so I can mount the lift to the desk. This sequence is the most important part of the whole build. The bearings for the drive screw must be mounted parallel to the drawer slides, or else, you guessed it, the whole setup will bind up as it moves. This is where the extra time is taken to ensure the whole job isn't wasted. Finally, I fabricated a mount for my 12-volt gear motor I selected so I can attach the motor shaft in line with the drive, via an anti-vibration coupler, of course. I was careful to line these up as best I could. This will mitigate runout and extend the life of the gear motor, the shaft coupler, and the bearings. From here, it's ready to run. So once I got the whole system mounted to the desk, I rigged up a simple push button, one for up, one for down. I've rigged up switching relays, one for up, one for down, and of course, limit switches for both. So from the buttons, you're able to start the system, and then it stops itself automatically once it's reached its limit of travel. The problem with this system is that it's extremely slow. I was running the whole thing on a 12-volt power supply because all of the components are 12 volts. I swapped out the motor to try to get a little bit more speed, but it just wasn't enough of a difference, so I ended up stepping to a 14-volt power supply from a Milwaukee tool that I had bought. And this works a little bit better, but it still takes 7 minutes to go through a complete cycle. Of course, if you ever need your monitor in an emergency, there is another way. Don't even need to speed up the video for that one. Works great.